Okay, day 671 off the grid, and this is very much the grid. Here's the 1923 Palmerston North power station. Here's one of the engines here. Vikey's up there. Yeah, they're going to start up this engine, so we should get some footage of that. There's the meter panel up there, which I'll go and film in more detail a little bit later on. Here's a, wow, this looks like some kind of rotary converter or something. Doesn't look like an engine, but it looks like we've got a generator and a motor here. Direct current generator. Oh no, wait a minute. Yeah, maybe. Here's the other engine, there's two engines in here. And here's the alternator itself, one of them. Pretty runty thing. I'd imagine that this smaller one at the end is the exciter. Pretty cool stuff, eh? We've got a bit of machine plant here, so doing a bit of work, drill press. It's an ancient old drill press here. Some old fuse panel there. Some power in here. These must be, I guess, the fuel tanks. Pretty sure these are diesel engines. Wow. Awesome.
G'day, how are you?
Oh, good, thanks. Yeah, good.
Yeah.
This is the first time I've been in here.
Is it?
Yeah.
Yeah. We'll be firing up at 3 o'clock.
Oh, yeah, that'll be really, really, really good. Yeah. So, do you operate the machines here?
I'm a part of the committee here.
Yeah.
I don't actually operate them myself. But,
is this power station still connected to the grid?
No.
It's not. So, no. It's only run for historical purposes.
Yes. But it is operational.
Yeah.
And if push came to shove, by putting some wires over the road, it could be made to work.
Okay, so it's all ready to go, and if there was an emergency, you could just, just strap it in and away you go.
Yeah.
Yep.
The lines go across the road, and they've been deliberately pinned so that at both ends, so that they can't be connected.
Oh yeah, yep.
It's easy to put up an overhead wire and sling it in if ever that need should.
Yep.
Yeah. But no, both the generators are fully operational.
And what's the capacity of each generator?
About a megawatt.
A megawatt each, oh yes, so you've got about 2 megs all up.
Yeah, 2 megs all up.
Would they ever run both machines together, or was one a standby?
No. In the day they would have both run together. Last year, during the drought, all the lakes ran dry.
Oh, okay.
In the late 60s it would have been.
Oh, late 60s.
Yeah.
Yep.
And they were actually used in anger, shall we say.
Yep. Wow.
This one's always run. That one's needed some work to get it recommissioned, but it's
oh yeah. And what fuel is it? Diesel or diesel? Just a standard diesel?
Yeah.
Yep. Same as you put in a truck or something like that. Wow.
Yeah. They're an 8-cylinder, 2-stroke, supercharged.
And this machine here, it looks like some kind of converter unit.
That was a start-up generator from a hydro station.
Oh, okay.
So this was the generator that was required to start the generating system.
Right. So that's it's the starter motor almost, or is it an exciter unit?
Well, it's I guess you could equate it to an exciter.
Yeah.
Like to get a power station running, you've got to have power.
Yeah, you've got to have power to energise the coils.
And likewise on the back of the generators, the generator's the big piece. The little piece on the back is the exciter.
That's the exciter. And the exciters are DC, are they, with permanent magnets?
That'll be a DC, and you can see the brushes actually going onto the slip rings on the alternator.
Oh yeah. And
Have a look at the.
okay.
You can see the brushes will be lifted off here,
Okay.
so that it doesn't work.
Yep.
So it produces DC off the commutator.
Yep.
And there's the two slip rings up on the alternator. So that carries the DC onto these coils.
Okay, on the rotor there.
On the armature.
Oh, it's armature, isn't it?
And the power is generated off the stator. There's the one.
Yep. So the output's taken from the stator windings. Yep.
Yeah. Just like in your car alternator.
Just like a car alternator.
Yeah.
Yep.
Which has a pair of slip rings on the armature.
Yep.
Yep. And the rectifiers in your car are off the.
And voltage regulation, does this have any facility to actually regulate the voltage? Like in a car alternator, of course, you can control the current through the armature to regulate the overall voltage.
That will be controlled. The important control goes back to the engine. The revolutions determine the frequency.
Oh, yep, right, of course. So
at 50 hertz.
So you've got to get it at 50 hertz. So you always lock
to it. Equates to 300 RPM on the engines.
Okay.
And of course, the important thing is that they are synchronised.
Yep, absolutely.
Coupled to the grid.
Yeah, it's got to
actually wait until they come into phase before you connect them.
Yep, absolutely.
If they're out of phase, bang.
Yeah. Back feeds and it's trying to run as a motor and all sorts of crazy stuff can happen.
In effect, what happens is they explode.
Yeah. And these engines, like those kind of motors that lock into that 300 RPM?
No. Once they're coupled, they'll maintain that.
Yep.
Right. The same thing happens with the turbines up on the hill.
Yep. Once they're connected in.
They all revolve at exactly the same speed.
Yep.
And the power output is determined by the pitch.
Oh yeah. Yep. How much power they take from the wind and convert.
Yes.
Yep.
So if there's light wind, it'll be pitched differently to a strong wind, but the revolutions must remain constant.
So in the same way, this will be running at the same RPM, but when it needs more power, it would suck through more diesel.
Yes.
Yeah, just more powerful explosions happening in the engine.
That's right.
Yep.
This is the old bathroom.
Yeah.
In the old shower.
So they're basically marine engines.
Shower.
Oh yeah. Same as what you'd have in a ship to run the propeller.
That's what they're made for. Yep.
Oh yep. Wow.
And the formulas were made in several configurations, and they just added cylinders. So the cylinder banks are in pairs or singles.
Yep.
So this has got 4 pairs for 8 cylinders. It's a 2-stroke engine.
Okay.
The big piece on the back is a supercharger, a square box at the end.
Oh yeah.
And if you have a look down the side of the engine, you'll see that the inlet is across the bottom rail there, and the intake's at the end, and the top one is the exhaust stack.
Oh yep. So that your ports are just right through in there into the cylinders.
And the ports are right, there's a cylinder blocks over there. So it's got ports in them. Air's forced in, and ports forced out.
So was it fairly common for marine engines to be 2-stroke engines in those days?
Yeah. Oh, yeah. In fact, it's quite unusual to find 4-stroke.
Okay, so you wouldn't really find a 4-stroke. Yeah. Is that just because when you're building your engine so big, it's easier just to arrange a 2-stroke?
No, it means you get power from every stroke rather than.
Oh, okay. So you're trying to. Otherwise, you need an engine twice as big to get the same amount of power effectively. Yeah.
Also, so a 2-stroke's really a very simple engine.
And more reliable, and obviously, especially if you're out at sea in a ship, you don't want to have your engine suddenly break down.
But the marine 2-stroke engines, if you looked at them, you probably wouldn't recognise them.
Oh yeah.
A lot of them now are made by Palmerston North, BMW.
All right.
They have a great big poppet valve in the top, big single poppet valve in the top. You know, everything. Most of them were 760 before in the bore, but now they're out to over 900 in the bore. Very, very slow revving. They go sort of that container ship we were on, 95 RPM flat out.
Yeah.
Wow.
And these big ones, 65 RPM.
Awesome.
Yeah.
Just really slow revving, so you're just getting your power from the
just torque.
Yeah.
And it means the propeller gets a real good dig at that water.
Yep. And so what's the mechanism for actually starting these? Is there
Compressed air.
Oh, okay. Yep. Right. You wouldn't obviously have a starter motor. That would be a little bit large. Yep.
Air tanks are there.
So these are air tanks. Okay.
Yes, and
Yep.
so the start mechanism automatically determines which piston has just gone past top dead centre.
Oh, yep. And that's the one it'll fire
That's
up the
that'll
compressor.
fire up on,
Yep.
and that will cycle through the cylinders in turn as the.
Oh, so it'll keep blasting air until it's started.
Yep.
Yeah, and then it'll automatically cut.
Because being a compression ignition, it's just the air compression that makes it fire.
Oh, the air compression actually does the initial.
All diesel engines have compression ignition.
Yep.
In other words, the compressed air gets so hot
Yep.
that when the fuel is injected, it burns.
The fuel just burns. Yep, from the pressure. Yep. And where's a compressor for charging up these tanks? Is that it there? No.
It's around the corner.
Oh, yep.
Somewhere, the compressor. Lola gear up. Been upstairs?
No, I haven't been upstairs
Oh,
yet.
okay.
No.
That's all the control gear.
Yeah. Thought to have a look up there actually and all that stuff.
Yeah.
And it's quite nice up there with all the tile work and stuff that they've got around.
Yeah. So it was all really too interesting to demolish, wasn't it?
Oh, yeah. Oh, it would have been a great pity.
But
Yeah.
it would have been a hell of a job demolishing it because each engine sitting on about 200 tonnes of concrete.
Yeah. No, it's great they haven't, eh? And at one point, I guess this power station would have powered the whole of Palmerston North.
It did, yes.
Yeah, and there would have been no grid connection. There would have been no grid at some point, eh?
In the early days, these engines weren't here. They were sort of the last engines. The standard engines are around through there. There's a picture and a bit of an explanation.
Oh, yeah. So these are the second lot of engines.
One of the pamphlets.
Yeah, I've got a pamphlet.
It's all described in there.
Yep.
And
Yeah, because it once.
I'm not fully familiar with all the history, but Val is very familiar with it. And Paul here with the check shirt on. He's the prime mover and shaker.
Oh, yep. So that because it once was upon a time where every sort of municipal authority generated their own power, wasn't there? And they had their own power stations. And was there any point in time where this actually contributed to the grid and ran with the grid?
Yep. Last done probably in the late 60s.
Oh,
when all the dams were low.
Oh, yep. So that
hydro system.
But I mean, before that, when it would have been generally used.
Yeah.
Yep. And would it have been used?
Ran on a regular basis.
Yeah. Would it have been used as a baseline plant or a peaking plant?
Probably baseline plant initially.
Oh, yep.
Yeah. And then it would have become a peaking plant. And of course, there was a financial tie-up whereby if the council who owned it,
yep,
if they ran it once a week, it entitled them to a big discount off their power bill from the supplier.
Oh, okay.
And so there was quite a tie-up there. I'm not sure what it was, but Bell would tell you exactly what that was.
Yeah.
So it was. How are you?
Awesome.
Pop up for a look.
Yeah. Oh, that's interesting.
That's really cool.
We're going to be going in 7 minutes.
7 minutes. Awesome.
Yeah.
Rockin' song there from AC/DC. Now I'm standing over by the left-hand engine where they're just getting ready to start it up. So you're actually going to hear the running of this massive British Polar engine made by British Auxiliaries Limited, Glasgow. You can smell the oil. It almost smells like a steam engine, but it's not. So is this engine currently in the starting phase, is it?
Yes, we're just pumping up the oil pressure now, getting it ready to kick her in the guts.
Awesome. So how long does it take to get the oil pressure up to the point where you can start it?
Oh, we could do it right now, but we're waiting for the time.
Oh, you're waiting for the...
Oh, we're late now anyway.
Okay. So you're going to fire it up now?
Yeah, I'll just find Bruce and the air on and then we'll go.
I was just speaking to Paul there from the Power Station Trust here, so looks like the engine's going to be starting any minute. What do you think of these engines, Vikey?
They're quite cool.
Do you think we need something like this at home for off the grid?
Yeah, I think so.
We could power the whole of Shannon off one of these.
Yeah, do you think?
I reckon so, quite easily. Yeah, 1 megawatt would probably do Shannon. Oh, it looks like we're about to start.
Here we go.
He's turning a valve which will... about ready to go. There we go. There's some valves.
Fuel's on. Yep.
Fuel's on. So this is the fuel supply down here, is it?
No.
No.
This is the water.
Oh, the water. For cooling?
Yep.
Yep.
Good afternoon, everyone. Basically, that station is built on station 4. It's originally run on 3 gas engines in the middle of the building, but they've been scrapped in 1955, and these two were replaced with these 2 diesels in 1936. Something like that, and these are still running. The power was running at the end of 1995 when the engine was shut down, and these get over on the scrap. So we took it over and
It's on. Fuel's on.
sound of the exhaust. Oh, we're outside now. Thought I'd see what the exhaust sounded like, and it's pretty quiet actually. These mufflers are really quite effective. So we're outside the Palmerston North power station, so here's communication. Have a look at these amazing meter panels. There's just a whole row of them all the way down. For each circuit, you got your amps, I guess 3 phases, of course, so there's 3 ammeters, isn't there? So you can see if your phases are balanced. This looks like switch gear. It doesn't look like straight on or off, it looks like some kind of... Yeah. Wow, there's some really cool stuff here.
It's all power.
Yeah, but I just love the tiled wall here, eh? It's really a work of art. Oh, here we go. Palmerston North Borough Council Electric Power Station. Works completed, power switched on April 1st, 1924. Mayor F.J. Nathan Esquire. Councillors F. Jackson, A.J. Graham, H.J. Canton, M.H. Oram, J.H. Odgins, M.A. Elliott, W.L. Fitzherbert, E.V. West, A.J. McLevy, and the town clerk was J.R. Hardy. Consulting electrical engineer F. Black, M.I.E.E. Contractors Turnbull and Jones Limited, and the borough electrical engineer was J.W. Muir, A.N.Z.S.C.E. Some letters after his name. So that's a little brass plaque that's on the wall of the switch gear. Oh, look at these, well, they're not exactly knife switches, they're those old kind of just contact switches. Those are really cool. good thing about those switches is you know what's happening in them, and the bad thing about them is, of course, if you touch them, you'll get a belt. Yeah. So it's some pretty serious stuff here, isn't it? Some pretty serious stuff. Now this is a shit you just don't see every day. This is a transformer bank here, I believe, and of course, well, jointing boxes and stuff. This is what actually took the power from the power station out into Palmerston North. As you can see, these are in fact transformers. In fact, no, maybe they're not transformers. Maybe in fact these are contactors. Yeah, I think these are I don't think these are transformers at all. I don't see any windings. No, these are contactors, but they connect to the transformers. No, they're definitely contactors, and the bus bars are behind there. There's some transformers here. But these don't look like they're hooked up. They're possibly outside, but there's some old transformers. Yeah, this is switchgear. This is serious switchgear. Look, this would have been connected not that long ago. Well, they say 1995. This was still potentially powered up. Look at that. Whoa. There we go. There we go. Oh, there's a little bit of a battery charge there. At flow charge voltage of 2.25 volts per cell. And this room here is like a kind of a storeroom of bits and pieces of old electrical stuff. I want to make a really long video on this, unfortunately, but we could. I mean, some of it reminds me of my shed, but tidier. Oh, there's our power station there. Look at this wee board here. It's the New Zealand power stations. Oh, the Cobb Dam, 32 megawatts. It's a pretty cool board too. Wow.
There was a toaster, like when you wanted.
Oh yeah, I saw the toaster, yeah. I saw the toaster. There's a kettle. It's a pretty funky old electric kettle, isn't it?
Look at this, how big this is. How about the Big Bang? Oh, this is an old kettle. It was an old kettle.
Hey? This?
Yeah.
Oh. Oh, it's some kind of gauge. It's got a big coil. I wouldn't know whether that's a timer or whether it's not a Selson or anything like that, is it?
What's a Selson?
It's a special kind of motor where you can dial in a degree at one end and the motor at the other end of the cable will copy that. Multimeters. Oh, yeah, I've always wondered about these, whether they were... Oh, I see, it's a remote reader. So you'd have the current transformer somewhere else and you just run a couple of wires out to this counter that would be on above the door. I've seen them on people's places. Okay, wow. Various old power meters here, time switches. The glass case for anti-tamper protection. Of course, Americans still have the glass case around them, or probably plastic on the smart meters, but we didn't have them for very long. And sort of most of ours are like that. Oh, it's raining now. Yeah.
That's why we have to stay here for a bit longer. Yes.
Aye?
You can reach the carrot.
Yep. Here you go, Adam. This is the clamp meter you want.
What?
Except this one will only measure AC. It won't have a DC function
You
in
have
it.
one.
But yeah, clamp meters have been around for years, long before digital meters. There were plenty of analog ones around.
And then you clamp this onto a wire, and you use the current.
Yeah, it'll read the current.
Dad's got one of these.
Oh, look at this old RCA oscilloscope here. That's pretty cool. We might have to stay until the rain stops.
I will measure the current for everyone.
Yeah. Right, anyway. I'll have a look at this. This is a... I've actually got one nearly the same as that in the shed at the moment. It still goes and I occasionally use it. Yeah, the old street lights with the power going to the top of them to these insulators. That's pretty cool. That's pretty cool.
Yeah, okay.
Not too long, no more than 5 minutes.
Okay. Alright, now this here is what you would call a volt clamp or something.
Current clamp.
Current clamp. And what you see here, I can just see here, you can open that, see, and you can clamp on a wire, see, like that, and you can snap it. Okay, I can't really do it here because there's no volt currents. So there are also some more cool things. You see, this is an old typewriter, and you've got an old fridge. This is what it's like inside it. Let this open.
You want to show me, Amy?
This.
Oh,
see?
that's the inside of a...
Yeah, this is...
That's the inside of a time switch. In fact, it's actually very similar to the one in your room. It's almost exactly the same. Look.
Yes.
See, there's the retard and advance control. There's the contacts. There's the disc which spins. That's the motor which runs it. And there's all the clockwork. In fact, this is the exact mechanism out of yours. It's just missing the dial, which is the bit that operates this cam here. See, look.
Right, now here is the bit where the ice comes through. It's quite interesting if you can just see it there.
Yeah,
that's cool. Super cool.
What's that?
Okay, now we're going to move on to some more cool things. Like a old toaster, which your dad would want. That's the old toaster. Look, you see there? You see that's cool. It's an old vacuum cleaner. Yes, ma'am. Hello. Smile. And now here is another old vacuum cleaner. It's quite interesting. And there's Amon. There's Amon. Is there anything you want to show me, Amon?
It's ticking.
It's a ticking.
Yeah.
Yeah, that's a heater, yeah. Yep.
I probably could hear it on the camera. Now, okay, is there anything else you want to show me around here?
Oh, look at this. It's got no glass.
Super old, you that. Now this is an old mercury rectifier, if you can see here. When you put mercury in that, it actually glows. That's quite interesting, isn't it? Alright, now this is an old school dentist drill. You drill in the teeth, which hurts you. So you just do it like this. Just so I get a glimpse of myself. So if you saw that. Okay, now there's also some other cool stuff. There's like that. And you see, here we are, this whole new lovely New Zealand. Now here is our power station. We could say Shannon's power station. It's called Mangahawa 19, and it's MW. And here is some cool stuff. You see? And here is some cool stuff. You can't really see it, really, the writing, but here is like an earth wire, that's what transport. Here's some of the armor and stuff. And here's some very interesting stuff over here. Here is, I have no idea what that is. It's some kind of sort of lamp. There's another big lamp. And I've got to say, there's a lot. And as I said in my announcement, you might want to come here on Mondays sometimes, because you could have a chance, a special chance of coming here. So you see here is like a cool scope. It's actually quite good. And this I'm on this. There he is. Look, okay, look, there he is. Is there anything else you want to show me?
Well, this is.
Oh, you want to show me these meters over here? Explain these meters.
But that time is still
Explain these meters.
This one's the old school. This one, look at this one. Look at all these.
Yeah, I see. Now, anyway, here is some cool insulators. And here's an old, super old book. Very old indeed. Here's home again. And well, can I have a look what you're saying? You're reading it?
It's an old maths book.
Yeah. And now it looks pretty cool. Wow. That's super cool. And that's an old drill. Like this from the Beauty and the Beast. Kind of rose in the jar. If I'll show you over here. See? And that's the dentist drill again. Mum, do I have a little go on it so I can film it?
The nasty drills.
Yeah, I'm glad I wasn't born in those days. What about you, Mum? Were you born in those days with those drills? Power to New Zealand, 100 years. It's supplying power to New Zealand. Your electricity supplier.
1888 to 1988.
Yep, 1888 to 1988. And it might come as a shock. Enough home and recent environments account for under 1 to quarter to 4 of all electrical accidents. That's of average of a shocking 58 of the fatalities. Electrical accidents, a real advantage averages in New Zealand. So here's some more meters. As I said, there are where?
Yeah.
Whereabouts?
Yeah.
Old sewing machine. Oh yeah, no, this is cool. Oh, what? Hey, Dad! 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 Yeah, it's going good. There's actually some. Yeah? Okay then. Bye. But no, I didn't get you.
Oh, you've turned it off.
No, I haven't.
Bye.
Bye!
Bye. Right, it's...
So it's just a matter of turning that, shut it down.
Just refurbishing the valve.
Oh, there's one really obvious question that I never asked anyone. What is the voltage that this alternator generates?
3,300 volts.
Oh yeah?
And then goes from 3,300 to 11,000 transformer.
Yep. Step up to the service lines. Yep. Is that still a typical voltage that these alternators would use in a lot of?
I'm not sure.
Yeah.
Oh, probably for the year I probably was, but
yep.
not now. And used
I'm just trying to remember what the ones up the Mangahal do. I think it is actually similar. It might be 6 kV.
6,000.
Yeah. I don't know if I'm supposed to be in here, but look, here's the smoko room. And look at these vintage lamp fittings again and heaters. Wow, they've got some cool stuff here, eh? They've got some really cool stuff here. Oh, it's an Ampex. Hey. Oh wow, look at that. It's a video recorder. Looks like a 1-inch machine, 1-inch reel-to-reel video recorder. What a funky cool thing to have. Nice. Nice. It looks like the sun's come out now again too, which is awesome. Oh wow. So,
6 volt.
yeah.
And away you go from there.
Okay, well this must be fairly old because look, there's a selenium rectifier stack in there.
So you're going back to say you've got to be 40 years old?
Yeah, well, wind power is nothing new. You know, I mean, people used to charge their radio batteries with wind power long before any kind of grid was around. Yeah, and of course pumping water, of course, using the, yeah. So, how many volts will these make?
6 volt.
6 volt, and
6 volt running 6 volt.
So that
6 volt electric fence unit.
Oh yeah, and would that be direct running, or would they have a little accumulator there too to keep?
I just don't know. I've seen even more. I'm not sure if this is my one or there's another one here. And there's 2 of them, I believe.
Wow, well, that's so cool. So where's the actual generator? It's right in the centre here, is it? Is it a permanent magnet?
Oh, that I don't know.
Ah. Because it's quite common now for a lot of people to build wind turbines when they build them themselves using the the gentle annie or smart drive motors. Because they've got the permanent magnets around around the hub, and the hub moves. And
the problem is going to get to the stage where those gentle annies disappear.
Yeah.
They're not being used or made anymore, and in the end they'll be used up and no one left.
Oh yeah.
And someone wants to have one of them for the museum. Well, sorry, they're all being made into wind turbines.
Yeah, true. A lot of commercial wind turbines now, though, have adopted the same arrangement for the alternators. So they have a hub with permanent magnets and a stationary coil, and take the power off as AC, of course, usually three phase. Funny thing is, though, there's always these people that believe that AC is better than DC at travelling long distances, and these people are quite convinced on that, but I don't really believe that because
DC from more to
exactly, and that's what I point out to them, If
it was better, they'd use AC on there.
Yeah, because it would have been simpler to use AC because you wouldn't have to rectify it and invert it at the other end. But yeah, I think the reason why people in the sort of the alternative power scene are confused is because generally when people are running DC voltages, they're running 12 volts, 24 volts, 48 volts. So you need, to get any kind of power out of it, you need thick cables, lots of current. But then when you go to AC, you're normally talking about 120 volts or 230 volts, so you've got a high voltage and relatively low current, so therefore the voltage or the power goes further. But it's not because it's AC, it's because it's high voltage. The resistance, a cable's going to have the same resistance whether you're putting 12 volts for it or 200, but of course that same resistance is going to take away less of the power for a given, like if you've got a voltage drop of 2 volts and you put 200 volts in at one end and get 198 out the other end at 10 amps, that's not going to be much power loss. But you put 12 volts down that cable and you get 10 volts at the other end at 10 amps, it's a significant power loss, yeah. That's what people seem to be confused about, is that they think that DC doesn't travel very far down cables, but yeah.
So you've got no wind turbine set up?
Well, I've actually got one, but I've just been meaning to find the time to get around to actually putting it up.
Oh, okay.
I've got a little 400 watt, what's it called? I can't remember the name of it now, but it's got like the rectifier, even the charge controller built right into the turbine. It's just like, so all you got to do is run wires to your battery bank and away you go. AirX, that's what it's called. And I got it real cheap off Trade Me too. Oh, wow, look at that, there we go. This is how the switch works. It's actually a pin, and these open up, and there's a socket. Would you better open that up here? Check this out. Ceramic and a big massive socket there, and as you wind the dial on the other side, this just snakes forward and plugs in, so it's like a massive plug-in socket, isn't it?
Pretty much, yeah.
So would that be hard out arcing as you tried to disconnect it, or would you only disconnect it when there was no load?
I'm not sure.
Yeah. Well, here we are in the Terrace End Cemetery, and I thought, well, since we're at the power station, You can see right up there from the cemetery is in fact the power station. It's a pretty cool sim. Pretty much in the middle of, well, not quite in the middle of town, but not far from it. Vintage cemetery. It's quite a cool sim. Used to hang out here a bit. When I first moved up to the North Island, I was still into hanging out in cemeteries in a big way. Don't do it so much now. Getting a bit older, you know. Say no more, say no more. But there's the power station up there at the top of the hill. So yeah, I think the boys are down there. It's a pretty cool sim. Right as far as this mausoleum up here. Wow. So if that's been repaired or it's been cleaned up. Yeah. There we go. There's the power station through the door there. Through the door. Alright. And there's the Baker Mausoleum power station up there. I should have filmed it from the inside, but didn't think of that. Maybe next year. Anyway, that'll do. Day 671 off the grid.